Rational exponents. An expression with a rational exponent is simply an expression with a fraction in the exponent. Yay, that's what the word rational means. You see that word ratio in the word rational? Ratio is a fraction. So it turns out that expressions with rational exponents can be written as radicals, which is why they belong in this lesson today. And radicals can be rewritten with rational exponents. So they can go forwards and backwards. So we have let x be a real number, so x is the radicand, and a and b be positive integers, so the bth root of x to the a can be rewritten as the bth root of x raised to the a. These are both the same. And then a third time over, we can rewrite this with a rational exponent, x to the a over b. Notice that the a exponent stayed the a exponent, but the b index moved to be the denominator. Okay, so we want to be able to do this forwards and backwards. First, we will practice converting the following expressions with rational exponents to radical form. We have 8 to the 2/9. So if I want to convert this to a radical form, well, first you need to make a radical symbol. The denominator 9 is going to go in the index. 8 will stay as the radicand, and then our little 2 can either go there inside with the 8, or it could go out here on the outside of the radical. For this purpose, we probably would like to keep it inside with the 8. So then I can reduce it slightly further because I know what 8 squared is. That is 64. This is my final answer. On our next problem, we have a polynomial 5x squared y, all raised to the rational exponent 2/5. So if I'm trying to rewrite this as a radical, first thing I want to do is make a big old radical symbol. Then I have the index needs to be the denominators. So this 5 is going to go in the index. In the radicand, I'm going to leave my parentheses, my base is over here, and all of this is still raised to the second power. Now I would actually like to finish this and make it a little bit cleaner. I still have the 5th root. Sometimes students, when they're moving to one step to the next, will forget to write the little index. If you do that, it's not going to be 100% correct and you won't get your full credit for it. So make sure you do that. Here I'm going to just distribute my 2 to all of the bases. So 5 squared is 25, x squared squared is x to the 4th, and y squared is just y squared. And that's my answer. One more problem when we have a polynomial with a fraction in the exponent. The radical symbol needs to be rewritten. Then we have the 4 in the denominator becomes the index. Inside the radicand, I still have the 3x raised to the 1. Well, that's kind of silly. No one writes raised to the 1, right? We can distribute that really quickly and get the 4th root of 3x. Next, I want to convert the following expressions with radicals to expressions with rational exponents. So basically the exact same thing I just did, but backwards. So notice that this is a radical expression and I want to rewrite it as a rational exponent. So the base 7 will stay the base. The 3 exponent is going to stay the 3 exponent, but the 4 in the index will just become the denominator in the exponent. And that's all you have to do. So the cube root of x to the 5th, the x stays the same. The 5th exponent, even though it's on the outside, it's still the exponent. It's the same as the 3 on the 7. So we have the 5 in the exponent, and then the index 3 becomes the denominator. So that's x to the 5/3. Please be careful when you're writing it that it doesn't look like this. X to the 5/3, that's not the same as what I wrote on the actual problem up here. X 5/3, that means like multiply, and that looks a little bit funny. When you're writing it, make sure you write a little 5/3. I know it's a fraction and then they're even smaller, but you have to make sure that it's small and elevated above the x. Alright, on the next problem we still have this 5x squared y squared as the base, and it's being raised to the 12, and this 3 index is going to be my denominator. Now on the previous two, 3/4 and 5/3 couldn't reduce, but 12/3 can. 12/3 reduces to 4. And then I can raise all of the terms to the 4 to finish us off. 5 to the 4 is 625. X squared to the 4 is x to the 8. And y squared to the 4 is y to the 8. So that's my final answer. And the reason I could do more on that one is because 12/3 reduced, and then I can distribute into the parentheses. On the last one, we have p stays the same. My exponent 20 stays in the exponent. The only thing that moves is the 5, and the 5 becomes the denominator in the exponent. Again, this one does reduce, so I'll do that. P to the 4. 20 divided by 5 is 4. On the next part, we're going to evaluate expressions with rational exponents. So when evaluating expressions with rational exponents, I want you to follow these steps. Step 1. Make any negative exponents positive by using the rule x to the negative 1 is equal to 1 over x. Step 2. Change the expression to a radical. Evaluating expressions with rational exponents is hard to do in your head, but we know how to evaluate radicals in our head, so if we change it to a radical, then we can do step 3 as simplify, much easier. On the first problem, 100 to the 1/2, the little 2 in the denominator becomes the index of the radical. Then in the inside I have 100 for my radicand raised to the 1. Well, no one really writes raised to the 1, do they? We have the square root of 100, and even this I don't need to write the square root. I can go ahead and erase that square root. Because if you don't have an index, you know it's an invisible 2. So the square root of 100 is just 10. So 100 to the 1/2 is hard to do in my head, but the square root of 100, that's pretty easy. So we convert it to radicals so that you can simplify quickly. So on this next one, again, I don't have any exponents of a negative, so I don't have to worry about step 1. Step 2 says change it to a radical. So I'm going to take that little 2, and that becomes the index. The denominator of the rational exponent becomes the index. The negative 25 stays in the inside as the radicand raised to the 1. Well, again, raised to the 1 doesn't really do anything, so we just have the square root of negative 25. So because it's a square root and the little index, which I don't really have to write, is even, are we allowed to take even roots of a negative number? Well, no. So this answer is not real. There is no such real number that when you multiply it by itself gets you negative 25. Now this next problem looks very similar, but it's not because there's no parentheses. Now this problem, because PEMDAS says exponents come before multiply and divide, is really more like negative 1 times 25 to the 1/2. The negative doesn't belong with the exponent because the exponent only applies to the thing previously before it. So the 1/2 exponent is only applying to the 25. Whereas on the blue problem, this 1/2 exponent was applying to the parentheses, and the parentheses included the whole thing. So I can probably fill this one out. We have negative 1 times the square root of 25 to the 1. And the square root of 25 is just 5, so we have negative 1 times 5, which is just negative 5. Remember, if there's a negative out in front, the answer is just going to be negative, and that has nothing to do with being real or not real. That's just going to be negative on the outside. So this next problem is more similar to the red problem than it is the blue problem, because the negative's out in front. I know my answer is just going to be negative. as if we had a negative 1 here. Now there's no negatives in my exponent, so I don't need to worry about step 1. Step 2 says change it to a radical, so the little 3 in the denominator of the rational exponent becomes my index. Then I have positive 64 to the 2. Now if I take 64 and square it, that's something very, very, very large. I don't know what that number is, and then you're going to ask me to cube root it after that. That's too hard. So what I'm going to do instead is I'm going to put the square on the outside. I can do the cube root of 64 in my head. I know that that is just 4. Now that I have 4, now I can square it. So 4 squared is 16, and 16 times negative 1 is negative 16. I find that a little bit helpful because it was too large for me to do in my head the other way. On our next problem, we have 100 over 9 to the 3 halves. So the denominator in the rational exponent becomes the index. I could cube the inside first, or I could square root first. Just like our last problem that I did over there in green, it's easier to make my numbers smaller and then cube them instead of cube them and make them really big, and then I have to take the square root, which is kind of hard. So I'm going to go ahead and do the inside first. The square root of 100 ninths, the square root of 100 is just 10. The square root of 9 is just 3. So the square root of 100 ninths is 10 thirds. And 10 thirds cubed is, because I still haven't done the cubed part, is 10 times 10 times 10, or 1,000, over 3 times 3 times 3, which is 27. On my next problem, we have a negative, but the negative is in front, so my answer is just going to be negative. I have 1/32 to the 2/5. 2/5 is not a negative exponent, so I don't have to worry about that. So I have the little 5 in the denominator becomes my index, 1 over 32, and I would rather figure out what that is and then square it instead of squaring 32, which is going to be too big for my head without a calculator. So the 5th root of 1 is 1. The 5th root of 32 is 2. If you go back and look at your page that we you're going to memorize. Then the negative, again, just continues to come along because it's on the outside. It's not being applied to the rational exponent. So we have 1 squared, which is 1, over 2 squared, which is 4. So my final answer is negative 1/4. Okay, so this is the first problem that we have a negative in the exponent, which is what step 1 said to take care of first. If you have any negatives in the exponent, make sure you make them positive by using the rule. So I'm first going to, he's not happy where he's living, and I'm going to move him downstairs. Now that I have that completed and I don't have any negative exponents, now I can change it to a radical. So that's 1 over the square root of 25 to the 1, which is just 5. So my final answer is 5. Again, we have another negative inside the exponent. So because there's a negative in the exponent, I want to make the exponent positive or happy by putting him downstairs. Now that he's in the denominator, I can, and positive exponent, I can proceed. I'm going to change that rational exponent into a radical expression. So I have the square root of negative 25 to the 1. Well, to the 1 really doesn't do anything, so I just have the square root of negative 25. And because the index is even, you are not allowed to take the even root of a negative, so this answer is not real.